question 5 of the final review is asking us to look at C3H6 and how it reacts with bromine. And then we're supposed to write the equation and state an observation that we would see with this reaction. So we can think about first, C3H6, what would that look like? If you remember our general rules, if we have CnH2n, we have an alkene. When we have an ENE, that means we have a double bond. If you didn't remember that fact, though, you could very easily draw this out and figure out if there was an alkene or if it was an alkane. So I would start out by drawing my 3 carbons in a row, and then I would start putting hydrogens around them. So 1, 2, 3, 4, 5, 6. And I would see, this carbon needs 2 more bonds. So it's not happy the way it is right now. This is not a good formula. So I would start over. I'd say, I probably need to have a double bond in there. So I can put it between the way I drew it, left to right, either the first and second one or the second and third one. Either way that we write it, if we write the name, it would be 1 for the ENE, just because whichever way we count, you start on the functional group side, so we'd be starting on carbon 1. This carbon has 2 bonds already. It needs 2 more. So we'll put 2 hydrogens on it. This one has 3 already, so it just needs 1 more. And this one has 1, so it's going to get our leftover 3 hydrogens. And now I have C3H6. So if you looked at this problem and you're like, yeah, I don't really know how it works, you would start out by drawing it out or realizing that CnH2n is an alkene. When you do have an alkene and bromine, which we remember is a diatomic molecule, so it's Br2, or instead of bromine, if we had hydrogen bromide, we'd have the same sort of reaction. They are going to react to form an alkane that is a bromoalkane. We're going to break the double bond. So I can either write it out or draw it out. Either way, IB won't care which way you do it, as long as you can answer all the questions in the end. So, carbon double bonded to another carbon. I know sometimes in class we go fast and we don't write out the hydrogens. If you're taking the final exam or the IB exam, make sure that you're writing out your hydrogens. Okay, plus my Br2. And again, that Br2 is going to break up that double bond. So our final is going to be C, single bonded to C, single bonded to the final C. That carbon on the end is still a CH3. This carbon still has that 1 hydrogen. This carbon still has those 2 hydrogens, and then we add some bromines to them. So 1 bromine went on each side of the double bond. The observation that we would see is that we would go from brown to colorless. We want to make sure we answer all parts of the problem. So we wrote the equation and we stated an observation. Part B, the product form in part A exists as an optical isomer. And it says draw the structural formula of the product and identify the chiral carbon atom. So we are looking at the atom that has the most stuff attached to it that would look the same either way, and that's that central one. We already have it drawn out. If you do that on the IB exam, why don't you redraw it out just so you know, so they know that you have it. And then finally, suggest the type of polymerization reaction that C3H6 undergoes and draw the structure of a section of the polymer chain formed by the 3 monomer molecules. So we're going to undergo for part C an addition reaction, or an addition polymerization reaction. And our parts of this would look like carbon, carbon, carbon. This carbon would have a CH3 attached to it. This carbon is going to continue going on to other carbons. It's just going to keep going and going and going, and it needs 2 more bonds, so 2 hydrogens. This one needs 1 more bond, so another hydrogen. This one looks like the one before, so we've got an H and an H. And it continues on, so now we're going to have the same pattern as before, a CH3 and a hydrogen. And we're going to, it says it wants 3 monomer molecules, so I'm going to have at least this group 3 times, so I need 1 more CHH, followed by a CCH3H, and then that is going to continue on for some n amount of times.